Hi everyone, my name is Dr. Muhammad Rihan. I'm going to provide a short review about design pattern. So allow me to share screen with you. In this short presentation, we're going to talk about what are design pattern, what are the advantages of using design pattern, what are the types of design pattern, and I'm going to give a conclusion. I'm using one of those design pattern as an example. In our case, we're going to talk about the factory design pattern. Design pattern are solution to general or recurrent problems that software developers always face during the software implementation. Those patterns represent best practices used, identified, and recommended by experienced software developers. Design pattern can help experienced and unexperienced developer speed up the software development. And for unexperienced developer, you can also learn to develop in a much easier and quicker way. From historical background, design patterns were introduced in 1994 when a book titled Design Pattern Element of Reusable Object Software was published by 4 authors. Those authors are later known as Gang of Four. After that book was published, many other design patterns were published and added to the pool of design patterns that every developer should use. There are several advantages of using design pattern. For example, software usability. A design pattern is designed once and can be used many times, which lowering the development cost and saving the design time. Design pattern also capture expert knowledge and design trade-off, which basically help in making design decision more efficient. A design pattern provides concrete, well-tested solutions. So this basically will take some of the design overhead from the developer and make developers concentrate more on items that does not have supporting design pattern for implementation. Of course, design pattern will make development faster. It will help developer write code faster, and it will provide clear picture how the implementation should have been done. It also provides standardization to the code. Using design pattern, developer can share the implementation details easier and more efficient. All in all, design pattern can help make software development faster, more reliable, more efficient, and more robust. Those are some of the references I used in my presentation. I used some material from those references as well. Feel free to browse those references. You will find much more topics than we're going to talk about today. Design pattern can be categorized into 3 main categories: creational, structural, and behavioral. The creation design pattern is responsible for object creation process. They define how object creation should be handled. A structural design pattern define how objects can be combined together, either through inheritance, composition, or any other approach. While behavioral design pattern specify how objects should be communicating with each other. Those lists actually has several examples of those design patterns, but not all of the design patterns that exist. As an example, we're going to cover the factory design pattern. So the factory design pattern is a creational pattern. It's a method or object whose primary purpose is to manage the creation of. We can use it as a method if the code changes are limited. However, if the creation process is very difficult, in this case, we should use a factory class or factory object rather than a single method. Target problem is simply the object creation, which sometimes could be difficult or heavy, and it should not be coupled or heavily coupled in the client code. Because if we do this, this means any change in the object that this client is using will involve many other changes that need to be done on the client side code. There are several advantages of using the factory design pattern. As you can see, it's simplifying the development process. It enhances software solution extendability. It also defers object creation to a dedicated object library or object code, limiting code change at client side, and speed up development time. We're going to have a quick example on using factory design pattern. So assume we have this problem. We need to design a software module that creates different types of vehicles. So if we're not going to use a design pattern, we're going to follow those steps, assuming those are the steps we're going to follow. We're going to create a class for each vehicle type. We're going to create a client class that accepts user input and accordingly create the proper vehicle. And we're going to create an instance of the client class on the main function and invoke it so the program can get executed. So to create a vehicle type class, we're going to create a vehicle base class. It has only, in our case, one simple virtual method, which is print vehicle, which we'll be using to identify the vehicle type. And here we define two more derived classes, two-wheeler and four-wheeler. Both of them is derived from the vehicle class and override the print vehicle method. They simply print different statements. Now, if we look at the client class, which should be responsible for creating the vehicle, we'll find this kind of if statement or if else statement. This one is basically checking user input, and based on the user input, it will create the proper vehicle object and then assign the created object to a pointer of vehicle class type, which is bvehicle. And this part of the code is a function main that basically creates an object of type client and create a vehicle type 1 and invokes this print vehicle method to get the vehicle information. Now, assume we decided to add one more vehicle. So what's happened in this code? First, we're going to add a three-wheeler vehicle. Now, once we have this, we'll have to go and change the client code and change the if-else statement to support the new added class. And here where the problem comes. When the new vehicle class is added, the client code has to be changed and recompiled. Okay? And we would like to avoid this, since this client class can be big, can be part of a big or a bigger program. So recompilation of all of this code would cause a lot of time delays. In this case, this design will be considered as a bad design, and would like to avoid this from happening. So let's look at the approach where factory design pattern will be used. In this case, the first step will be the same. We're going to create a class for each vehicle type. However, we're going to add a method in the base vehicle class that will take care of the vehicle creation process. And from the client code, we're going to invoke the vehicle create method with the proper vehicle type parameter. So as you see, the changes are not major, but the effect is very important. So here is the vehicle create method. It will basically check the vehicle type, and based on the type, it will create the proper vehicle object and return a pointer to it. By doing this, all the client code will not be changed anymore. All the client has to do is just to call vehicle create, and the same rule apply for the function main. And this is the beauty of the factory design pattern. Just to go quickly over how the design pattern will look like from UML diagram, we will have the vehicle base class and any other vehicle that will be added later as a derived class. The client code will be outside the factory code, and the application, the main entry point, which is function main, will also be outside the main vehicle code. So in this case, any change will come to this yellow block only. In summary, using factory design pattern, object creation is no longer the client responsibility. The library or the factory class vehicle is now responsible for object creation process with all of its complications and conditions. Client just need to call this library to create an object and get the object pointer in order to access it. Thank you.